Hi guys, welcome back. This is KC4 review, and we're going to go over target 4B. So number 6, determine the approximate interval where the profit is decreasing. So if I'm looking for decreasing, I'm looking to where the graph from left to right, reading it from left to right, just like if you're writing or you're reading a book, where that is going down. Right, so if I look from left to right, I'm following my graph from left to right, I see that it starts to decrease here and go down. Okay, so that highlighted part, that's the decreasing. We use our x values to determine where it is decreasing. Okay, so it looks like it's from this 100 to the 200. So we're going to write that as 100, comma, 200. And put those right in parentheses there. And again, remember you use your x values for decreasing. 100 to 200. You always do the lowest first, the highest, right? You're reading left to right. Okay, number 7. Determine the interval where the seller earns a profit. Okay, so if a profit means that they are making money, so positive values. We have positive money. You guys should know what a profit means here. So if we look, right, I don't want selling price of Play-Doh here, right? I don't want anything down here. That means I'm losing money. -0 all the way up to something down here, that's losing money. I want a, profit where 0, -5, I'm losing money, all the way up to 15, that sounds more like I want to make $15, not lose -$5. Okay, so anything in here is where I'm going to be making money. So if I go all the way, anything up here is from here all the way up here, our profit. That's where I'm going to be making money. It's positive. Okay, so where is that happening? Okay, that's happening anytime the Play-Doh is $0 through $8. So I'm going to write that as 0, 8. Okay, and I'm going to use these parentheses because it means we're not including 0 or 8. So in words, we're earning a profit over this entire highlighted interval. But interval, but not including $0 or $8. Okay, the reason that is because if you sell Play-Doh for $0, meaning it's free, you're not going to make any money. And if you sell Play-Doh for $8, it looks like that this $8 over here, it just got too expensive, so people didn't buy it. So you didn't make any profit if people aren't buying. So that's why we're doing 0 to 8, not including 0 and 8, just those open brackets. All right, moving right along. Number 8. This one has to do with Angry Birds. If you guys recognize this, this is an Angry Birds picture. And what this says is, in the context of the image below, explain the meaning of the domain. So first of all, we have to realize that the domain are x values. Right, and this is our x-axis along here, and this is our y. So we only care about these values from here to here. That's our x values, our x-intercept. That's domain. So there's a couple of things that this could mean. If you launch an Angry Bird starting right here, and it goes all the way over here, we know that it's going to land right there. So there's answer number 1. Okay, there's a couple answers for this. So answer 1 could be that it's the distance the Angry Bird travels until it hits the ground. Right? From the slingshot until it hits the ground, it could be the distance. So we'll write that as the distance that the Angry Bird travels, how far it's traveling from the slingshot to the ground. Okay, that could be one answer. That could be what the domain is representing. Or you could look at it as the time. If this was time, how long is it in the air? It's traveling, traveling, traveling. Now you're counting, taking a couple of seconds. Finally, it hits the ground. So it could also represent the time it takes the Angry Bird to hit the ground, depending on what this x-axis is labeled. So another answer, answer 2, is the length of time, my keyword there is time, that it took for the Angry Bird to hit the ground. Let me fix this. For the Angry Bird to hit the ground. Okay, so those are 2 possible answers there. Either one is fine. Okay, number 9. You're going to need your calculator for number 9. We'll get that. If you don't have one, go grab one and put this in with me. Know how to use your calculator. Okay, number 9 says a projectile launched from ground level. The path of the projectile is modeled by the function f of p is equal to negative 4.9 p squared plus 39.2 p. Find the domain of the function. So just to kind of plan out what we're going to be doing here, domain are our x values. Okay, so what are those x values that where our projectile launched from the ground with this function? So we need to go to our calculators, and I'm going to plug in this function here. I'm going to go here, and our function is, we'll go to new document. No, I don't want to save that one. Add graph. Okay, so I'm going to plug in this here. So I have negative 4.9 x, x, which is RPs, squared plus 39.2 x, right? We use p's. I'm just going to use x's. Same thing. It's just a variable. It's just representing something else. Okay, I'm going to hit enter, and here is my graph. Now we can't see this whole graph, but that's fine. We only care about the domain, so we can see the domain right here. And we want to know where this is starting and ending on our domain. So I can go to menu 6, which is analyze graph, and I'm going to find the 0. So I'm going to put my cursor on the left of the first 0. There's the 0, right? And to the right, make sure I'm covering it, and there's our first 0. 0, 0. I'm going to do that again. Menu 6, just analyze graph, find the other 0. So put it to the left. Here's the other 0. To the right, and that says 8, 0. Now with domain, we're looking for x values, which is the first number in both of these coordinates. So 0 to 8. 0 to 8, that's what we care about. That is our domain. I'm going to go back, and I'm going to write from 0 to 8. Now we can include the 0 and the 8. Remember, our graph looked something like this, and it was 0, 0, and then it said 8, 0. You want to sketch it on yours, go ahead. And we use the x value, 0 and 8. That's how I got the 0 and 8 here. Okay. Now we're including 0 and 8 because that's when it's starting and it's ending. So we're going to put square brackets around those because we're including 0 and 8 this time. All right, last one, number 10. So within the interval 0, less than or equal to x, less than or equal to 6, you want to determine the times when the function is increasing. So the first thing we do with these problems, this problem 0 and 6, let me get a highlighter here. 0, again, we're looking at x values, so I'm looking along the x-axis. That 0 happens right here, which on our graph, that 0 for the x value is also represented by that dot there. And then the 6, I'll use yellow, 6, right? 6 is on the x-axis right here. I go up, there it is on my graph. That's where x is going to be 6 on my graph. So we're only looking in between these 2 points, from 0 down, back up to 6. We don't care about this other stuff. That's not in our interval. Okay, determine the values when the function is increasing. So when I find increase and decreasing, I read from left to right. So I'm going to follow this. It looks like we're going down. So looks here, I'm going to start to increase. Okay, and I have to look at my x values. Okay, so I'm going to look down here where I started to increase, which was 3. And it looks like I go all the way up here. Remember, I only care in between these points there, which is 6. So from 3 to 6. Now be careful, because the answer is not 3 to 6. This is telling us it's time in years, since 2000. So this is really 2003 and 2006. So 2003 to 2006 is where we are increasing. And now B, determine when our function is decreasing. So I'm going to use pink for this one when I'm decreasing. And I saw when I was traveling along this graph from left to right, I started to go down. So that is my decreasing, right? And if I wanted to, whoops, go right down here. No. There we go. If I'm decreasing, right, we only care from this point, that 0, to here. We don't care about this stuff up here, so I don't need to highlight it. And so those x values, I will use right here. From here, I look down at my x values, that's 0, all the way to this point here, which is 3. So from 0 to 3. But again, we're in years, so we're going to write that as that 0 is 2000 to 3, which is 2003. And then we want to know in which year was the average serving per person eating vegetables the least. So the least amount, that's the same thing as our minimum right here, this point. So that point, the least right here, I'm drawing an arrow, the least. When does it happen? Right, I want the year. So I look at this and I look at the years on our x, which is that 3, which is 2003. That is the least value there. Okay, guys, go ahead and move on to target 4C video.